Here I have a Tektronix 314 analog storage oscilloscope. Whenever a beam writes on the display, it gets stored in the display. Here I have a Tektronix 2230 digital storage oscilloscope. You can store waveforms digitally. It's flickering. Okay, yeah, there. Okay, you can see it stops flickering at some points, but it can have XY plotter output, so I have some oscilloscope probe cables and banana jacks and alligator clips hooked up to the Z axis and the X and Y axis. And once I press the start button, like this, it will start plotting on this oscilloscope. That it's drawing a waveform. Right on the screen of the this oscilloscope, you can also see it drawing on this one, but this is digital. This is not analog storage, so it's not going to store on the screen, but it is going to store on this one because this is analog storage. You see it's printing out the cursors. There's the trigger point. It's writing out the multiple division. Oh, I need to erase this. I put the gain too high. I have to restart. There we go. I put the gain a little bit too low this time, but it should get the whole thing in, I guess. There's our square wave. This square wave was taken from this sort of switch mode chopper supply. There's a lot of ringing in there, and you can see the ringing at the rising edges of the waveform. Okay, so there's the readout, 5 volt. That dot is the ground point, so this entire line here is ground. And there's the time. It's not reading here fully because there's burn-in, but if you look closely enough, you can see it says 10 microseconds, I think. And there's, of course, tech. And it's writing the delta voltages. And then delta time. .8 microseconds. It's the period of this waveform. So if I have a calculator, like here, so 20.8 times 10 to the power of -6, and then inverse that, approximately 50 kilohertz. It's 48 kilohertz, but around 50, which is what I set this oscillator to, so that checks out. You can see everything being written here. Tektronix. There, Tektronix 2230. There we go. I'm done. There we go. We got the readout from it, which is really nice. It got plotted on this analog storage oscilloscope. My setup works as follows. The XY outputs, of course, just go to the probes. They're DC coupled. You go into the XY channels, that's pretty easy. You have to set the gain and everything and get it all right. Use the vernier knobs. And you can do that by going into the setup and holding this for like 2 seconds. No, actually 1 full second, 1 Mississippi, and then it starts the setup procedure. And you can use that to adjust the gain and everything to get the windows in. And as for the x-axis, I mean not the x-axis, I mean z-axis, I'm using this battery. So what this oscilloscope has is a relay that closes when it's supposed to blink or unblink. It has a relay, it has a dual pole, no, it has a single pole dual throw relay. You see it says relay common, and then relay normally open, and on the bottom relay normally closed. You can sort of see it there. Yeah, normally closed NC. And that's what I have it connected to. So when it's not wanting to make a beam, when the beam is off, the relay is closed, which sends the voltage from this battery into the z-axis, a positive voltage, so it blinks the beam. But when the oscilloscope wants to draw a beam on the plotter, the relay is open, and then this disconnects the battery from the z-axis, and then the beam can write again. Let me show you what happens if we don't have the z-axis. It'll produce okay results, but not the ones that are typically desired. You'll see. Look at this. Already. You see this line? It went from the center position, and then without the beam blinking, it drags along and draws here, and then it starts to draw the waveform. Look at that. It's retracing back to draw the cursors. This is why the z-axis is important. You'll see once I reconnect the z-axis, all the poor not blinking traces disappears. But look what happens if I disconnect the blinking. Look at that. Look at that. It's writing tech perfectly. Look at that. Just reconnect blinking. It's good like that. Disconnect blinking. Now it just turns into a fuzz. You see the characters are combining with each other. You'll see it be more prominent when it writes the tech logo. Yeah, there we go. It drew across the entire screen. You see all the characters up there are being connected together. Let's blink again. Nah, no more connecting. Fancy pantsy. Oh, that's all I wanted to show you now. Okay, bye-bye.